Hello, I'm Claire Penrose, the General Manager, Asia Pacific at the Global CCS Institute. I'd like to welcome you all to our webinar today. I'm pleased to see that we have attendees from around the globe watching in on our webinar. Today's webinar will present the major findings of a CSIRO-led investigation into the potential environmental impacts of amine-based post-combustion capture technologies. This study was commissioned by the Global CCS Institute. It measures the actual emissions from a pilot capture plant at the AGL Loy Yang power station in Victoria, Australia. Our presenter today will be Dr. Murched Aziz. I'd now just like to introduce Dr. Aziz. He's a Chief Research Scientist at the CSIRO Energy Technology Australia and Research Leader for Emissions from Energy Cycles. Dr. Aziz has over 20 years' experience in industrial and government research organisations, and his technical skills include chemical engineering, atmospheric science, and air quality monitoring. Very shortly, I'll hand over to Dr. Aziz to lead the webinar. But before I do that, I'd just like to give you a little bit of information about how today's webinar will work. We'll have the presentation, and at the end, I will moderate a question and answer session. At any time during the webinar, you are welcome to submit your questions through the Questions tab on the Go To Control panel on your screen. When we get to the end of the presentation, I will pose your questions to Dr. Aziz for him to answer. I hope that we'll have many questions and that we'll be able to get through as many of them as possible. However, any questions that we aren't able to answer in the time allowed today, we'll be happy to get in contact with you afterwards. The webinar will be recorded and available on our website, along with a copy of the presentation in the next few days. So now, without any further ado, I will hand over to Dr. Aziz to give his presentation. Thank you.
Hi, I'm Murched Aziz from CSIRO. Thanks, Claire, for the introduction. Today, I would like to present you a study, results of the study which we carried out for the Institute related to emission from amine-based PCC plants, and where we really went into a real case study for real flue gas coming from a coal-fired power plant. As a PCC plant was using the monoethanolamine solvent. So as we all know, a lot of studies were carried out in labs or theoretical studies predicting different type of degradation products, where we went from 20 compounds to 50 compounds, 100 compounds, and the list may not end. However, the real problem is what's happening in the lab may not be representative of what's happening in real plant with a real flue gas. And in here, we will see some of those results which we obtained from the Loy Yang power plant. So this presentation will deal with different topics. First of all, how we will carry out proper emission measurements from a real power plant flue gas. How we'll take these results and analyzing them to identify major compounds. Then can we do any study in relation to their potential degradation in the atmosphere? Do we have appropriate chemical mechanism describing this photodegradation process? And once we determine this, then these pollutants will be emitted to the atmosphere. So the emission dispersion, which we carry out to calculate and predict the ground level concentration, will determine if the appropriate procedures for allowing this plant to operate with good licensing will go ahead or not. And we'll explore the major findings of this study. We have two reports which produced during this study. That these reports are uploaded on the Global CCS Institute website, given below. So why are we talking about environmental impact of amine-based PCC plants? So the question which we have, a flue gas coming from a power plant will contain different type of compounds, including CO2, SOx, NOx, particles, etc. Now, rather than allowing for this flue gas to go ahead directly from a stack, it will go through pre-treatment procedures before entering a proper PCC plant. So in this case, at Loy Yang, our flue gas was washed with caustic soda and with a drum knockdown to collect particles and other compound before entering the absorber. And we made sure that most concentration, they are below number 2 ppm for SOx and NOx and 10 microgram per cubic meter for particles. So as we can see here, the flue gas will go into the absorber where will interact with the amine, and CO2 will be bonded to the MEA. Then it will be transported after that to a stripper operating at 47 degrees C, where the CO2 molecule will be released under the heat and go into the CO2 stream, clean stream. And the lean solvent will go back to the absorber. And on top of the absorber, we have a water wash system allowing to reduce any potential emission from the plant before being emitted to the atmosphere. So what we expect to go out from the PCC plant, different type of pollutants, including some of reactive or non-reactive pollutants. Non-reactive pollutants, we know exactly how to deal with them. However, reactive pollutants, we need to assess if we understand their atmospheric chemistry, or if not, we need then to explore this atmospheric chemistry to determine, okay, their photodegradation. And once we understand this, then we can move into air quality modeling. So it is a full process. So as I said, whatever comes into the process will not go out into the atmosphere. Some of these compounds will stay in the process. Others, they will go straight forward into the exit, to the stack, such as NO. And in the process, we will see different type of compounds being produced, and they may be released to the atmosphere. So what we need to do, we need to develop appropriate techniques and procedures to identify and collect the data from PCC. We need to develop chemical mechanisms to describe atmospheric degradation of the selected solvent, in this case, the MEA. Once we develop that, we can predict ground level concentration of major pollutants which represent concern in the atmosphere. And by developing these, then a generalized framework to assess emission from PCC plant will be developed and can be communicated, results can be communicated to regulatory agencies. And this project has benefited a lot from other projects which was running on parallel and funded by ANLEC. And the results from the ANLEC project help us to finalize and improve many of these results obtained. So as we can see in this picture, okay, the Loy Yang power plant is operating with brown coal, and the PCC plant is operating with MEA, monoethanolamine. In Australia, we don't use FGD or DINOX to clean the flue gas. However, as I said before, we have pre-treatment using caustic soda system and knockdown drum as well before entering the absorber. And the Loy Yang plant is located in Victoria, Australia. And here we can see the slipstream which we're taking from the exit flue gas, getting indirectly into the PCC plant, as I'm showing with my mouse indicator. And the PCC plant, it is at the bottom right of this slide. So measurements has been carried out at different locations of this plant. And here we can see, okay, the flue gas coming in, knock out a drum using an AOH. Then everything goes into the blower, and we have collected different type of data, and we sampled at different locations of this plant. And definitely we sampled after the water wash, before the water wash, and before entering the absorber at different locations as indicated in the picture. Very important is really we needed to develop appropriate techniques to collect data from this new system which operate on saturated conditions. We need as well to develop new procedures for analytical analysis for quantification of different pollutants, such as nitrosamine, nitramine, or any alkylamines. All this has happened, and what we will do with this data. If we have identified data where we don't have information about their photodegradation, at CSIRO we have the smoke chamber facility where we can investigate the photooxidation of amine or any other volatile organic compounds. We assess their degradation, we collect data where we can develop and validate chemical mechanisms. The smoke chamber is a clean environment where we have artificial lamps, and in this case we have 18 cubic meter volume for this smoke chamber. The chamber is equipped with different type of analytical measurements for gases, and as well we can collect aerosols from the chamber to investigate their composition. The results from the chamber for MEA was carried out for different type and different concentration for NOx, volatile organic compounds, and MEA that will be representative of what's going to happen in the atmosphere. Once we collect all these data, a database will be formed, and our simulation for developing the chemical mechanism will have started. And here, in this case, we have developed a mechanism for the degradation of MEA, where we validated it and we tested using real emission from the Loy Yang PCC. An example of this chemical mechanism for the MEA is presented to the right. It involves about 35 chemical reactions, and it includes nitrosamine reactions in it and measured degradation pathways for the MEA. And as we can see, we validate this model against data from the chamber showing underneath. Here we are showing performance in terms of ozone, MEA, and formaldehyde, aldehydes, ammonia, and aerosols. Okay, since we have developed this chemical mechanism, okay, it's very important now to prepare all simulation scenarios to carry out air quality modeling. And in here we are showing the plant, Loy Yang plant location in the Victoria state, and the Loy Yang, it's showing this graph. It has, the Loy Yang A has 1,000 megawatts, 7 million ton per year CO2. And we have a stack height of 250 meters. So definitely, because it's a retrofit case where we try to understand, okay, if we retrofit this Loy Yang plant with a PCC system, of course, we are not going to build a new stack, so we use the same stack. That's why it is 250 meters. So data from this Loy Yang power plant will be added, okay, to different type of emissions occurring in the area. As we know, we have in different type of industry, different power plants. We have emissions from transport sectors. We have biogenic emissions coming from trees, from grass, depending on the weather. And all these, we put them into a grid cell scenario database, which forms the emission inventory. And in this emission inventory, okay, we allowing for to get into transported into by and dispersed by meteorological and dispersion parameters. So the wind field will dictate how this plume will be advected. And once it is advected, we will plug the chemical mechanism which we have developed and couple it with a more complete chemical mechanism. In total, we will get up to 390 chemical reactions into this chemical mechanism, allowing at each time step to calculate the ground level concentration at different level and different for a grid cell 250 by 150 kilometers. Once we collected this, we include the dry and wet deposition into that one, and we can look at human health impact and ecosystem impacts if we have high concentration. So any perturbation to the system which we have coming from the power plant then will be reflected into our air quality modeling. So major findings from this research which we carried out, in here we emission at the absorber outlet. And we are showing here the solvent liquor, the water wash liquor in milligram per liters, and concentration at inlet gas stream, absorber outlet, after water wash outlet. And we determined here, we presented monoethanolamine, ammonia, methylamine, ethylamine, dimethylamine, nitroso dimethylamine, nitrosomorpholine. And for nitroso compounds, the units, they are microgram per liter. And what is telling us, okay, major finding from these results, sampling results from the plant. Okay, before, we are showing here before the control option, I mean the water wash, and after the water wash, engineering control as is showing in here. We can see practically in this process, before the water wash, for MEA, we have up to 260 while milligram per cubic meter, but after water wash, we didn't see much. And ammonia, of course, we've seen releases up to 170 milligram per cubic meter after the water wash. And if we look at methylamine, ethylamine, formaldehyde, and acetone, the numbers are there, and we can see some compounds that will be emitted after water wash. Nitrosomorpholine, the same thing. After engineering, we have very, very limited, negligible data, negligible amount of nitrosomorpholine being emitted, but they have been taken into account. So the engineering control refers to this water wash column at the top, did work and control part of these emissions. And in the smoke chamber, when we collected when we simulated different concentration for MEA and NOx, we can see, for example, in this case, ozone could be formed, ammonia will be formed, MEA has been degraded, and different type of compound. Really, it's a photochemical precursor. MEA, we can say, is a photochemical precursor for formation of ozone and secondary organic aerosols. And one of the major findings as well, okay, for selected cases, okay, MEA will produce some aerosols in the atmosphere. So we need to take account of this into our modeling. Okay, from the modeling which we carried out at Loy Yang, here I'm presenting some of the major findings, ozone and PM2.5. So if we look at business as usual case for 1 hour ozone from all sources, and we know from the plant we have emission of NO, we notice due to titration we have reduced the amount of ozone in this area. And definitely we have no ozone problem from PCC plants. And we have benefit in terms of reduction of ozone down to 1.5 ppb. In terms of PM2.5, as we can see, the PCC contribution has reduced the amount of PM2.5 resulting from emission from the power plant. And this reduction was really based on the reduction which we've seen from SOx emissions. And we can see here the benefit from using PCC to reduce, not to capture only CO2, but to reduce other criteria pollutants such PM and ozone. So what about here ammonia? Definitely ammonia, which is recognized as a major degradation product of monoethanolamine, okay, has been produced. And here we identified less than 60 ppb of ammonia being produced at localized location around the plant. However, these 60 ppb of ammonia being produced or less, okay, was comparable to concentration resulting from soil fertilization in the north of Gippsland area. What happened with the nitroso and nitramine predictions? Since we know that everybody is worried about what would happen for nitrosamine, nitramine emissions, and we all understand that some nitrosamine will be formed in the process, and some of them are able to escape the process, such nitrosomorpholines, and others, such as andela, will stay in the process. And in here, if we accumulated those nitrosamine, which they were identified after the water wash and including them in the modeling, really the levels, they are very, very, very low to picograms per cubic meter. So once we look at these results, okay, it was very hard really to continue and do any health risk assessment because this perturbation is very, very, very small and negligible. Okay, we went out now to see what we have done and what are likely to be emissions from PCC. Without engineering control measures, such as using water wash or acid wash, MEA, ammonia, acetaldehyde, acetone, formaldehyde are likely to be emitted from the plant. Level of nitrosamine and nitramine released from the plant were negligible. And using our modeling and specification for the plant remember, we are using 250 meters stack. Flue gases from the power plant fitted with PCC are expected and will be much cleaner with lower level of pollution than with a plant without the PCC technology. And we can see in here, okay, emission from power plants operating with coal-fired power, will reduce criteria pollutants from the plant. What are the emission formation mechanisms and atmospheric dispersion expected from a PCC process? To be able to answer these questions will depend on what type of amine we are using. For example, if we didn't have the chemistry of monoethanolamine being developed, it wouldn't be possible to predict what would be the ground level concentration of or degradation product of this solvent. And that's why we recommend the smoke chamber experiment to be carried out in a proper way to determine the degradation of any solvent to be used in the future for CO2 capture. I would like to mention in here, gaining knowledge from the ANLEC project and from the Global CCS Institute project, we have modified the CSIRO smoke chamber, and now we have a new smoke chamber where we remove most of potential artifacts that may alter our results due to different compound or materials in building of the chamber. So this chamber is ready now to be used. Our atmospheric dispersion can be used to determine different type of weather conditions and air quality impacts. And for the case study which we selected for the Loy Yang power plant, we used mainly convected conditions. And this scenario was carried out when we had pollution from plant back burning. We had transport of air pollution from Melbourne City moving towards Loy Yang region, and the valley where the Loy Yang plant is operating was still under strongly convective conditions, under clear sky conditions. Those convective conditions, as we all know, okay, is one of principal mechanisms by which buoyant plume from stall stack can be brought down quickly down to the ground. And it should be considered a worst case scenario. And despite all these modeling scenario conditions, we didn't see much impact from the plant. And the other thing which I would like as well, how to control these emissions, definitely proper engineering control, if needed, can be deployed to eliminate, minimize any type of emissions in the future which we may be required to reduce. With these adequate engineering measures in place, quantities of emission will be kept under control. Okay, and finally, I would like to say here we have developed a generalized environmental framework for assessing emission from PCC plant. Definitely, this framework can be applied for other amine PCC plant, not just for MEA. In here, we have developed validated and implemented best practices to collect data from the plant. For example, how to do the stack sampling, what material we can use, how to conserve targeted compounds, how to transport them. At the same time as well, we have developed and validated analytical procedures to isolate and quantify major components and trace products in the process. So a wide range of analytical techniques were used to identify and to quantify the solvent, alkylamine, ammonia, amides. And we are very happy with these results. We have established atmospheric chemical reaction for reactive pollutants, including monoethanolamine. Currently, we are pushing towards including piperazine. We have updated chemical transport model to include this atmospheric chemistry of MEA and coupling it with much more detailed chemical mechanism for air quality modeling. Ground level concentration of pollutant were determined, and local regional air quality assessment for potential use of PCC can be carried out if needed. All these framework which we have developed in here will give good ammunition to regulators, to the industry, and to scientists to communicate on scientific ground basis for how best we can deploy this technology, which is readily available to control CO2 from power plants and other industry. On behalf of my colleagues, I would like to acknowledge the financial assistance of the Institute, GCCSI Institute, and also I would like to acknowledge the Australian National Low Emission Coal Research and Development for allowing us to access their data that we benefited from them during carrying out this project. I would like to thank you everybody for listening to us from Australia, CSIRO.
Excellent. Well, thank you, Dr. Aziz, for that presentation. Now, if anybody has any questions, you're very welcome to enter them in English, please, in the GoToWebinar control panel that you'll see on your screen. We've actually already had a few questions sent in during the presentation, so I might move straight to those. So, Dr. Aziz, the first question I've got here is that in this study you tested using the MEA solvent. Do you have plans to conduct these tests for other solvents?
Yes. Our intention is really to understand the behavior of other solvents once they are being emitted from any plant, CO2 plant, PCC plant. Yeah.
Okay, great. So the next question that we've got here is, what is the biggest challenge for sampling at this pilot capture plant? And why was this challenging?
Okay, as you know, we are dealing with a non-conventional flue gas in the stack. And saturated, a very complex matrix we have to deal with. And part of what we've seen is a direct interaction between what compound we are sampling and some materials which we have in the sampling gear. So we removed all these artifacts while we were doing the operating at Loy Yang power plant. It took us a bit of time to understand what's going on.
Okay, great, thank you. So I've got a couple of questions here about the flue gas pre-treatment process. The first one is there a problem with carryover of caustic soda into the absorber?
Well, the caustic soda, we didn't see any caustic soda moving into our absorber. However, the caustic soda, which we assessed the effect of caustic soda in a different project, and we have different results in this aspect, and I don't think presented any problem for us to continue using caustic soda, no.
Okay, great. The other question we've got here in relating to the flue gas pre-treatment process is, what is the stoichiometric ratio of caustic soda to SOx that's removed?
Ratio caustic soda to
SOx.
SOx. I need to get back to the person who answered this question because I don't have this number right now with me.
Sure. What we'll do is we'll make sure if you send through those details to us that we'll be able to pass them on to the person that asked the question.
No
All right, so moving away from flue gas pre-treatment processes now, the next question is about the nitrous amines in the solvent. So they're saying that the nitrous amines in the solvent is a function of time. How old was the solvent during the measurement presented here in your study?
Okay, I think this I didn't mention this during my talk. What we used in here, we used an aged solvent, and which was has over 800 hours of operation, and it has been documented in the report, quite detailed in that.
Okay, great, thanks. Back onto flue gas pre-treatment. The question is, what salt species are formed and how is the wastewater treatment performed?
Okay, the wastewater treatment, we didn't look at this stage. It wasn't part of what we were going to look at, but it is in our future plan, yeah. So what was the first, yeah.
All right, no worries. This may be a similar type of question, but I've got another question here, which is in the wash section configuration above the absorber. Yeah. How are you preventing the accumulation of the contaminants in the wash water loop?
Because it is it's circulated most of the time.
Mm-hmm. Okay, great. The next question is about the absorbers. So there were two absorbers, as I understand it, used in the pilot plant, and normally we would see only one. Do you think that the use of two absorbers affected the results in this study?
No, we tested this and we modeled this, and the only reason why we have two absorbers because this plant was really meant to move around and put in a semi-trailer and move around, and put the whole big in one absorber, it wasn't feasible. That's the only reason why we put two absorbers. But no, results will not change now.
Okay, great. All right. So the next question I have here is, were there any SOx aerosols in the incoming flue gas from the power station? And where are those removed in the flue gas pre-treatment? Oh, sorry, and were those removed in the flue gas pre-treatment or in the wash water?
Well, I really this question about because we didn't. Well, our coal has low sulfur content, so it didn't present much problem for us. Right. And when we tested for, I know probably when we tested for SO3, we couldn't see much. So really, we don't have data on this because our coal is very low in sulfur.
Right, right. So it wasn't something you were focusing on examining. Yeah, sure. All right. The next question we've got, and they're flowing in, so this is great to see, but I encourage people to keep on sending them in if they've still got more questions, because we've got plenty of time. But the next question we have is, was the particulate concentration measured at the absorber or the pre-scrubber inlet?
Okay. What we were going to do in the absorber, we were going to collect some particles using the LP system. However, for different reason, a technical reason, we didn't continue, and with time of the project, okay, we had to finish it. We couldn't do the work which we intended to do with the aerosol. But it can be done. It's not really complicated. because we had all gear to do that. Yeah.
Okay, great. Our next question's coming in here to say that the wash water was efficient for the MEA. Do you think it will be equally effective for all amines?
I think we would like to test that. I wouldn't go and say yes or no, something which we have to look at. Yeah.
Okay, great. Next question I've got here is about the washing column. So there is a washing column at the outlet of the absorber, and the question is, what is the structure of this?
Structure of the absorber. Okay.
Is there a spray nozzle or structured packing?
It's structured packing, yes.
Structured packing, great. All right, the next question we've got here is, do you think that the sampling and analysis methodology that you've used in this study could be applied elsewhere? For example, do you think it would be equally applicable for post-combustion capture processes for black coal power stations or natural gas power stations?
I would imagine yes, because it wasn't really the flue gas has affected, it's the chemical reactions and products which were formed during the degradation of the amine. Yeah, they can be used.
Okay, great. It's good to hear that it could have a possibly wider application.
Yeah.
So the next question I've got here is for the water washing section. Is the water used pure water, or were there any chemicals added?
No, okay. I imagine it was pure water. Yeah.
That's something more about that the plant operators would know.
Yeah.
Sure.
But I can get back to you about this.
Okay, all right. Thanks for that. Look, folks, the questions are starting to slow down here on the webinar. If you have any more, please send them in. But I have one last question here at the moment. It's a sort of a back to basics one. So in your experience, are the emissions in the flue gas the same between a coal-fired power station with and without post-combustion capture?
Sorry, I didn't catch this properly.
So do you think that the emissions in the flue gases from a coal-fired power station with post-combustion capture are the same as the emissions out of flue gases with coal-fired power stations without post-combustion capture?
No, that will be different because most of compounds such salts, NO2 and so on, will be captured. Particles will be less, and definitely they will be different. And we'll have less emission with PCC than normal flue gas.
Great. All right. Had another question come on in there. They're really flowing tonight, which is great. So tell me, did you find any nitrosamines in the chamber experiments?
Yes, we did. Nitrosamine in the chamber.
Yeah.
Yes, we did.
In the smog chamber experiments.
Very tiny.
Could you tell us a little bit about that?
Okay, nitrosamine has been found in the smoke chamber experiments, but at very low level.
Right. Okay.
And
great.
Has been confirmed many times. Yeah.
Right. Excellent. Do you think there's any points that we haven't covered in this Q&A session, Dr. Aziz, that you just wanted to reiterate from your presentation?
I think what I would like really to emphasize on during this discussion is definitely for future PCC plans to be approved and to show it is environmentally sound, we need to understand the atmospheric degradation of amines used in the PCC. This area is still not really fully understood. We understand now very well MEA, but we have to do for other property amines or property solvents or other amines such as piperazine, AMP, or so on.
Mhm. And that's something that, as part of your work at CSIRO, you're considering doing?
We'll do this one in collaboration with solvent developers and other interested parties.
Mm. Excellent. All right. Well, thank you so much for a very informative presentation and for patiently answering all of the questions that have come through today. I certainly know that in my conversations with people in the CCS community that there is a lot of interest in the research that you've been doing and a lot of interest in the results that you've shared with us today. So on that note, folks, I might thank Dr. Aziz for his presentation.